Imagine a world where machines think like humans. This isn't science fiction, it's happening now. Artificial intelligence and machine learning are changing everything. They're in our phones, cars, and homes. They're reshaping industries and solving complex problems. The AI revolution is here, and it's transforming our world in ways we never thought possible. AI and ML are not just buzzwords, they're powerful technologies that are already part of our daily lives. When you ask Siri a question, that's AI. When Netflix recommends a show you might like, that's ML. These technologies are making our lives easier and more efficient. They're helping us make better decisions and discover new possibilities. But what exactly are AI and ML? AI is the broader concept of machines being able to carry out tasks in a way that we would consider smart. ML is a specific subset of AI that trains a machine how to learn. Think of AI as the brain, and ML as the process of teaching that brain. Together, they're creating a future where machines can understand, learn, and adapt. The importance of AI and ML today cannot be overstated. They're driving innovation in every field imaginable. From healthcare to finance, from transportation to entertainment, AI and ML are revolutionizing how we work and live. They're helping us tackle global challenges like climate change and disease. As we continue to develop these technologies, their impact will only grow. Artificial intelligence, at its core, is about creating machines that can perform tasks that typically require human intelligence. This includes visual perception, speech recognition, decision-making, and language translation. AI systems can analyze vast amounts of data, recognize patterns, and make predictions faster and more accurately than humans in many cases. Machine learning, on the other hand, is a subset of AI. It's the process by which AI systems improve their performance on a specific task through experience. Instead of being explicitly programmed to perform a task, ML algorithms use data to learn and improve on their own. This ability to learn and adapt is what makes ML so powerful and versatile. To understand the relationship between AI and ML, think of AI as a car and ML as the engine. The car, AI, is the overall system designed to get you from point A to point B. The engine, ML, is what powers the car, allowing it to learn from experience and improve its performance over time. Just as a car can have different types of engines, AI can use different types of ML algorithms. The importance of AI and ML in today's world cannot be overstated. They're driving innovation across industries, improving efficiency, and solving complex problems. From personalized recommendations on streaming platforms to early disease detection in healthcare, AI and ML are enhancing our lives in countless ways. As these technologies continue to evolve, their impact on society will only grow. Artificial intelligence is a vast field with several branches, each focusing on different aspects of creating intelligent machines. One of the main branches is machine learning, which we've already touched on. But there are others that are equally fascinating and important. Let's explore some of these branches to get a better understanding of the AI landscape. Natural language processing is a branch of AI that focuses on the interaction between computers and human language. It's what allows machines to understand, interpret, and generate human language. When you use a voice assistant like Siri or Alexa, you're interacting with NLP technology. This branch of AI is also crucial for things like automatic translation services and sentiment analysis in social media. Computer vision is another important branch of AI. It deals with how computers gain high-level understanding from digital images or videos. This technology is used in facial recognition systems, self-driving cars, and medical imaging. It's what allows a machine to see and interpret visual information, much like a human would. Robotics is a branch of AI that focuses on the design, construction, and use of robots. This field combines mechanical engineering, electrical engineering, and computer science to create machines that can interact with the physical world. From industrial robots in factories to humanoid robots designed for social interaction, robotics is pushing the boundaries of what machines can do. Machine learning is often described as the engine that powers many AI applications. It's a method of teaching computers to learn from data without being explicitly programmed. This ability to learn and improve from experience is what makes ML so powerful and versatile. Let's dive deeper into what ML is and how it fits within the broader field of AI. At its core, ML is about creating algorithms that can receive input data and use statistical analysis to predict an output while updating outputs as new data becomes available. This process of learning from data allows ML systems to improve their performance over time. For example, an ML algorithm might be trained on thousands of images of cats and dogs. As it sees more images, it gets better at distinguishing between cats and dogs. There are three main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, the algorithm is trained on a labeled dataset, meaning we tell it what the correct output should be. Unsupervised learning involves training the algorithm on an unlabeled dataset and letting it find patterns on its own. Reinforcement learning is about training algorithms to make sequences of decisions through trial and error. Machine learning is a crucial part of AI because it allows systems to learn and improve without human intervention. This is what enables AI to tackle complex problems that would be difficult or impossible to solve with traditional programming. From spam filters in email to recommendation systems on streaming platforms, ML is behind many of the intelligent features we interact with daily. Section 5. Real-world applications of AI and ML. The applications of AI and ML in the real world are vast and, well, growing every day. Let's start with healthcare, where these technologies are making a significant impact. AI and ML are being used to analyze medical images, predict disease outbreaks, and even assist in drug discovery. For example, AI algorithms can analyze mammograms and flag potential abnormalities for radiologists to review, potentially catching breast cancer earlier. In finance, AI and ML are revolutionizing how we handle money and make financial decisions. These technologies power fraud detection systems, algorithmic trading, and personalized financial advice. Robo-advisors use ML algorithms to create and manage investment portfolios based on an individual's risk tolerance and financial goals. This makes professional-level investment strategies accessible to a broader range of people. Transportation is another area where AI and ML are making waves. Self-driving cars are perhaps the most well-known example. These vehicles use a combination of sensors, ML algorithms, and computer vision to navigate roads safely. But it's not just cars. AI is being used to optimize traffic flow in cities, improve public transportation scheduling, and even in the development of flying taxis. In the realm of customer service, AI-powered chatbots are becoming increasingly common. These chatbots use natural language processing to understand customer queries and provide relevant responses. They can handle a large volume of inquiries simultaneously, 24/7, improving customer satisfaction and reducing the workload on human customer service representatives. Some advanced chatbots can even detect customer emotions and adjust their responses accordingly. Section 6. How AI and ML work. A simple explanation. At their core, AI and ML work by processing vast amounts of data to recognize patterns and make decisions. But how does this actually happen? Let's break it down into simple steps. The first step is data collection. This is the raw material that AI and ML systems use to learn. The data can come from various sources: images, text, sensor readings, or any other type of information relevant to the task at hand. Once the data is collected, it needs to be prepared. This involves cleaning the data, removing errors or irrelevant information, organizing it, and sometimes transforming it into a format that the ML algorithm can understand. This step is crucial because the quality of the data directly affects the performance of the AI system. As the saying goes in the ML world, garbage in, garbage out. The next step is training the model. This is where the magic happens. The ML algorithm processes the prepared data, looking for patterns and relationships. It adjusts its internal parameters based on what it finds, essentially learning from the data. This process can take a lot of computational power and time, especially for complex tasks or large data sets. Finally, the trained model is tested on new data it hasn't seen before. This helps us evaluate how well the model has learned and whether it can generalize its knowledge to new situations. If the model performs well on the test data, it's ready to be deployed in the real world. If not, it might need more training or adjustments. This cycle of training and testing is often repeated many times to refine the model's performance. Section 7. Types of machine learning. Machine learning comes in several flavors. each suited to different types of problems and data. The three main types are supervised learning, unsupervised learning, and reinforcement learning. Let's explore each of these in more detail. Supervised learning is like learning with a teacher. The algorithm is given a set of input data and the correct output data. Its job is to learn the relationship between the input and output. For example, if we want to teach a computer to recognize cats in images, we might show it thousands of images labeled as cat or not cat. The algorithm learns to identify the features that make a cat a cat. Once trained, it can then classify new unlabeled images. This type of learning is used in many applications, from spam filters to facial recognition systems. Unsupervised learning, on the other hand, is like learning without a teacher. The algorithm is given input data without any corresponding output data. Its job is to find patterns or structure in the data on its own. This type of learning is useful for tasks like clustering similar items together or reducing the dimensionality of data. For instance, an e-commerce site might use unsupervised learning to group customers with similar buying habits. Reinforcement learning is a bit different. It's like learning through trial and error. The algorithm, often called an agent, interacts with an environment and learns to take actions that maximize some notion of reward. This type of learning is used in game-playing AI, robotics, and autonomous vehicles. For example, a reinforcement learning algorithm might learn to play chess by playing millions of games against itself, learning from its wins and losses. Section 8. The future of AI and ML. As we look to the future, it's clear that AI and ML will continue to transform our world in profound ways. One exciting area of development is in natural language processing. We're moving towards AI systems that can understand and generate human language with incredible fluency. This could lead to more advanced virtual assistants, real-time language translation, and even AI-generated content that's indistinguishable from human-written text. In healthcare, we're likely to see AI playing an even bigger role in diagnosis and treatment. Imagine AI systems that can analyze your genetic data, lifestyle factors, and medical history to predict your risk of certain diseases and recommend personalized prevention strategies. We might also see AI-powered robotic surgeons performing complex operations with superhuman precision. The field of autonomous vehicles is set to explode in the coming years. We're not just talking about self-driving cars, but also autonomous drones for delivery, self-piloting aircraft, and even space exploration vehicles guided by AI. These technologies have the potential to revolutionize transportation and logistics, making them safer, more efficient, and more accessible. Another exciting frontier is the intersection of AI and quantum computing. Quantum computers have the potential to solve certain types of problems much faster than classical computers. When combined with AI, this could lead to breakthroughs in areas like drug discovery, climate modeling, and financial forecasting. The future of AI and ML is bright, and we're only scratching the surface of what's possible. Section 9. Ethical considerations in AI development. As AI and ML become more powerful and pervasive, it's crucial that we consider the ethical implications of these technologies. One major concern is privacy. AI systems often require large amounts of data to function effectively, but how do we balance this need with individuals' right to privacy? There's also the question of data ownership. Who owns the data that AI systems learn from, and how should it be used? Another important ethical consideration is bias in AI systems. If an AI is trained on biased data, it can perpetuate and even amplify those biases in its decisions. For example, an AI system used in hiring might discriminate against certain groups if it's trained on historical data that reflects past discriminatory practices. Ensuring fairness and preventing discrimination in AI systems is a major challenge for developers and policymakers. The potential for job displacement due to AI and automation is another ethical concern. While these technologies can create new jobs and increase productivity, they may also render certain jobs obsolete. How do we manage this transition and ensure that the benefits of AI are distributed fairly across society? This is a complex issue that requires careful consideration and planning. Finally, there's the question of AI safety and control. As AI systems become more advanced, how do we ensure that they remain under human control and aligned with human values? This is particularly important for AI systems that make high-stakes decisions, like those in healthcare or autonomous vehicles. Developing robust safety measures and maintaining human oversight are crucial as we continue to advance AI technology. Section 10. Getting started with AI and ML. If you're intrigued by the world of AI and ML and want to get started, there are many resources available. First, it's important to build a strong foundation in mathematics and programming. Courses in linear algebra, calculus, and statistics are essential for understanding the underlying principles of ML algorithms. For programming, Python is a popular language in the AI/ML community due to its simplicity and powerful libraries. There are numerous online courses and tutorials that can help you learn the basics of AI and ML. Platforms like Coursera, edX, and Udacity offer courses from top universities and tech companies. Andrew Ng's machine learning course on Coursera is a popular starting point for many. For a more hands-on approach, you might try Kaggle.com, which hosts ML competitions and provides data sets for practice. Books can also be a great resource. Artificial Intelligence. A Modern Approach by Stuart Russell and Peter Norvig is a comprehensive textbook on AI. For ML specifically, The Elements of Statistical Learning by Trevor Hasty, Robert Tibshirani, and Jerome Friedman is a classic. For a more accessible introduction, Machine Learning for Absolute Beginners by Oliver Theobald is a good choice. Once you've got the basics down, the best way to learn is by doing. Start with small projects that interest you. This could be building a simple chatbot, creating a program that recognizes handwritten digits, or developing a recommendation system. As you gain confidence, you can tackle more complex projects. Remember, the field of AI and ML is vast and constantly evolving, so continuous learning is key. Section 11. Embracing the AI future. As we conclude our journey through the world of AI and ML, it's clear that these technologies are not just shaping our present, but are the key to unlocking our future. From healthcare to finance, from transportation to entertainment, AI and ML are revolutionizing every aspect of our lives. They're helping us solve complex problems, make better decisions, and discover new possibilities we never thought possible. But with great power comes great responsibility. As we continue to develop and deploy AI systems, we must remain vigilant about the ethical implications. We need to ensure that these technologies are developed and used in ways that benefit all of humanity, not just a select few. This means addressing issues of privacy, bias, job displacement, and AI safety head-on. For those of you inspired to dive into the world of AI and ML, remember that the journey of 1,000 miles begins with a single step. Start with the basics. Build a strong foundation, and then let your curiosity guide you. The field is vast, and there's always something new to learn. Whether you're a student, a professional looking to upskill, or just someone fascinated by technology, there's a place for you in the AI revolution. As we look to the future, one thing is certain: AI and ML will continue